In this video, we are going to learn about the factor and the remainder theorems. Before we get started, let's kind of recall what we learned last class. So if you will go ahead and pause this video and try these two warm-up questions here and just see how you do with these two warm-up questions. When you are ready, resume the video and I will go over them with you. So it says, state if the given binomial is a factor of the given polynomial. To do this, I am going to use synthetic division, and we want our remainder to equal 0. So if the remainder equals 0, then it is a factor because it goes in evenly. And if our remainder is anything but 0, then it's not a factor because it doesn't go in evenly. So for example 1, my polynomial is written in standard form and there are no missing terms, so I'm going to go ahead and write down those coefficients. So my coefficients are 1, -6, -17, and -90. Inside of this box is going to be +9. Again, that comes from this term right here. If I were to solve this for x, we would get 9. I'm going to bring down my first term of 1. And whatever I have last over here will be my remainder. So 9 times 1 is 9. -6 plus 9 is 3. 9 times 3 is 27. -17 plus 27 is 10. 9 times 10 is 90. -90 plus 90 is 0. My remainder is 0, so yes, this is a factor. So my answer is yes. Let's try example 2. So when I look at this, I'm checking to see if my everything's in standard form. And here I go 4, 3, 2, 0. I'm missing an x term, so I need to add in a 0 as a placeholder for that x. So my coefficients are 1, 6, -40. 0 is in there for the placeholder, and 6. If I were to solve this for x, I would get -10. You always want to bring down your first term, and whatever you get last is your remainder. -10 times 1 is -10. -6 minus 10 is -4. -10 times -4 is +40. -40 plus 40 is 0. -10 times 0 is 0. 0 plus 0 is 0. -10 times 0 is 0. 6 plus 0 is 6. We want to know if x plus 10 is a factor of this polynomial here, and we got a remainder of 6. Because our remainder is 6, our answer is no. It can only be a factor if it goes in evenly. It only goes in evenly if your remainder is 0. So that's just kind of going over how we learned about synthetic division last class. And let's look at example 1. On example 1, it says divide x cubed plus 8x squared plus 5x minus 14 by x plus 2. So I'm going to use synthetic division for this. So when I look at my polynomial is written in standard form. My exponents for x go 3, 2, 1, and 0, so I am not missing anything. So my coefficients are going to be 1, 8, 5, and -14. In this top left box, -2 is going to go there, because if I were to solve this for x, I would have to subtract 2. I always want to bring down that first coefficient, and whatever is last is my remainder. Negative 2 times 1 is negative 2. 8 plus negative 2 is 6. Negative 2 times 6 is negative 8. Or sorry, not negative 8. That was silly. It's negative 12. 5 plus negative 12 is negative 7. And then negative 2 times negative 7 is positive 14. Negative 14 plus 14 is 0. So when we divide it, remember that you always start with 1 degree less than what you started with. I started with a degree of 3, so this is going to be a degree of 2. And so my answer is 1x squared plus 6x minus 7. So next it says the remainder was 0. This means that the divisor is a factor of the polynomial. Let's check this by multiplying the factors together. So what they're saying is that x plus 2 is a factor because our remainder was 0. The other factor is our answer. So if I multiply x plus 2 by our quotient, the answer that we just got, we should get our original polynomial back because we're saying that this is a factor of this. So here I have a binomial being multiplied by a trinomial, and we learned how to multiply this by using the area model. So I'm going to go ahead and do that here. I'm going to take my binomial and write it down the side, and I am going to take my trinomial and I am going to write it across the top. X times x squared is x cubed. X times 6x is 6x squared. X times negative 7 is negative 7x. 2 times x squared is 2x squared. 2 times 6x is 12x. And 2 times negative 7 is negative 14. So when I combine like terms, I'm going to get x cubed, and then 2x squared plus 6x squared is 8x squared, and 12x minus 7x is 5x minus 14. Well, if we look at this, this is exactly the original polynomial that we started with. So this proves that x plus 2 and x squared plus 6x minus 7 are factors of this original polynomial. So this shows that the product of x squared plus 6x minus 7, the product of x plus 2 and x squared plus 6x minus 7 is the original polynomial, which is what we have right here in blue. So the divisor is a factor of the original polynomial, and what we just discovered is the factor theorem. So this factor theorem is written down here, and it says for any polynomial p of x, x minus a is a factor if and only if p of a is 0. And again, this part right here is saying if the remainder is 0. So it is a factor if your remainder is 0. So let's look at that on example 2. It says show that x minus 2 is a factor of f of x equals 9x cubed minus 11x squared minus 21x plus 14. Then write f of x as a product of x minus 2 and another factor. So to start this, we're going to do synthetic division. We start our synthetic division with our polynomial. Your polynomial always has to be in standard form. So this is in standard form, and it is not missing anything, so I do not need to use 0 as a placeholder. So that's because my exponents for x go 3, 2, 1, and 0. So my coefficients are 9, negative 11, negative 21, and 14. You always are going to begin by bringing down your first coefficient. And then we want to divide this by x minus 2. And so positive 2 is going to go in our top left-hand corner. And whatever I get here is my remainder. So let's see what we get. So 2 times 9 is 18. Negative 11 plus 18 is 7. 2 times 7 is 14. Negative 21 plus 14 is negative 7. 2 times negative 7 is negative 14. 14 minus 14 is 0. So the first thing they asked us to do is show that x minus 2 is a factor of this. We showed that because the remainder is 0. The next thing they want us to do is to write f of x as a product. Remember, product means that you're multiplying, of x minus 2 and another factor. So if x minus 2 is a factor, then our other factor comes from our answer. We started with x cubed, so my answer is going to begin with x squared. So the other factor is 9x squared plus 7x minus 7. This entire thing, these two factors, are my answer. Let's look at example 3. Part A. Show that x plus 6 is a factor of g of x equals x cubed plus 6x squared minus 16x minus 96. Then write g of x as a product of x plus 6 and another factor. So this right here has the same exact directions as we did in example 2. So we're doing the same process. So let's try that to start. You always want to check to see if your polynomial is in standard form. And here it is. My exponents go 3, 2, 1, and 0. So we are in standard form. We are not missing anything. And so I can go ahead and do synthetic division with this. So my factor, or my coefficients, I should say, are 1, 6, negative 16, and negative 96. If I want to divide by x plus 6, then negative 6 is going to go up here. And then whatever I get here will be my remainder. So, negative 6 times 1 is negative 6. 6. Oops, sorry, I was just looking at the wrong thing. 6 minus 6 is 0. Negative 6 times 0 is 0. Negative 16 plus 0 is negative 16. Negative 6 times negative 16, I'm pretty sure that's 96, but let's double check. Gonna grab my calculator. Let's see. Yes, it is. Oops, 96. And negative 96 plus 96 is 0. So we've just shown that this is a factor because our remainder is 0. So my factors are x plus 6, my divisor, times, let's see what we get here. I started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So my other factor is going to be 1x squared plus 0x, so I don't need to write that, minus 16. So this is my second factor, and so this is g of x written as a product of x plus 6 and another factor. Let's move on to part B. Part B says factor g of x completely. Hint, write g of x as a product of linear factors. So right now my factors are x plus 6 times x squared minus 16. Now you may recall that x squared minus 16 is a difference of two squares. We learned how to factor a difference of two squares. You could either use the area model, or you can recall that if you have a difference of two squares, you factor it like this. So if I have a minus b squared, then the factors are a plus b times a minus b. So I'm going to bring down my factor of x plus 6. Here, what's being squared in this first term? Well, x plus what's being squared in the second term? 4. So x squared minus 16 factors to x plus 4 times x minus 4. This is now factored completely. Remember, linear factors means that your highest exponent is 1, and that is how you know that you are 100% done with factoring. This is our answer. Whenever you're doing problems like this, you always want to factor completely. It will not always be scaffolded for you to tell you to do so. You need to know that you always want to factor down. So everything that we did in Unit 1, it's coming back full circle. I told you that you would need to know how to factor for the remainder of the school year. So this is where that's coming in. We will continue to use it throughout the year. Let's look at examples 4 and 5. So on example 4, it says evaluate p of x equals 2x cubed plus 4x squared plus 5 at 3. So this is telling me that x equals 3. So I'm going to have p of 3 equals 2 times 3 cubed plus 4 times 3 squared plus 5. Now go ahead and pause this video and evaluate this. Remember, p of 3, this is just function notation. We're just evaluating this side over here. You can either use a calculator or you can use the order of operations. Either way, you want to go ahead and figure out what this equals. I'm going to use a calculator. And so I'm going to have 2 times 3 cubed plus 4 times 3 squared plus 5. And when I do that, I get 95. For example 5, it says divide 2x cubed plus 4x squared plus 5 by x minus 3. When I look at my polynomial, it is in standard form, but it is missing an x term, so I'm going to have to add in a 0 as a placeholder for that x. And so my coefficients will be 2, 4, 0, and 5. In my left-hand box, I'll have a positive 3, and I'm going to bring down that first coefficient of 2. So 3 times 2 is 6. 4 plus 6 is 10. 3 times 10 is 30. 0 plus 30 is 30. 3 times 30, what did I do? Three times 2 is 6. This is going to give, oh, I didn't do anything wrong. I'm not looking for 0. Sorry about that. And so here my remainder is 95. What I want you to notice is that when we evaluated, we got 95. And when we did synthetic division, we got 95. You're getting the same thing. And so if you look here, p of x was the same as our polynomial over here. And then when it says evaluate at 3, that's what we were doing here. So we did the same exact thing 2 different ways, and in the end, we got 95. This is the remainder theorem. So if a polynomial p of x is divided by x minus a, then the remainder is p of a. So instead of having to plug into all of this and calculate that using the order of operations or a calculator, you could do synthetic division, and your remainder is what it equals if you were to evaluate it using function notation. So on example 6, it says factor the polynomial given that f of k equals 0. So this is telling you right here that the remainder is 0. So if the remainder is 0, then you know it's a factor. So let's go ahead and try this one. So I'm looking to see if I'm in standard form, and I am. My exponents for x go 3, 2, 1, and 0. So I can go ahead and write down my coefficients. That's 4, -4, -9, and +9. Over here, they're telling me that k equals 1. So 1 is the number that's going to go on my left side of the box. I'm going to bring down my first coefficient, and whatever I get here is my remainder. Now, my remainder should be 0, because they're telling me that when I plug it in for this, I get 0. So let's see what happens here. 1 times 4 is 4. -4 plus 4 is 0. 1 times 0 is 0. -9 plus 0 is -9. 1 times -9 is -9. 9 plus -9 is 0. So yay, I got 0 as my remainder like I knew I would. And now I want to go ahead and write my factors. So let's see. If k equals 1 as a factor, then that means that k minus 1, if k equals 1 as a solution, then that means k minus 1 was a factor. Because the only way I can get a positive 1 here is if I have a -1 inside, because I would need to add it to get a positive 1 here. For down here, I started with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So my factors are going to be 4k squared. Sorry, these should all be k's. Let me fix that. So k squared, k to the first, and k to the 0th power. So it'll be 4k squared plus 0k, so I don't have to write it, and then minus 9. You always want to make sure that you have factored completely. K minus 1 is linear because my highest exponent is 1. But can I factor this one anymore? Well, this is a difference of 2 squares. Dots. Difference of 2 squares. For 4k squared, 2k is being squared. And for 9, 3 is being squared. So now this is factored completely because all of my factors are linear. And so this is my answer. Let's look at example 7. It said, given one zero of a polynomial function, find the other zeros. Remember, your zeros are your x-intercepts. So here you're wanting to get solutions. So we want to figure out what x equals. So I have 15x cubed minus 119x squared minus 10x plus 16. And then on the end, we have the semicolon and an 8. This is telling me that one of the solutions is x equals 8. So I'm going to go ahead and do my synthetic division. with 8 in the upper left-hand corner. Here, this is in standard form. My exponents for x go 3, 2, 1, and 0. So I'm going to have 15, negative 119, negative 10, and 16. I'm going to go ahead and bring down that 15, and whatever I get here is my remainder. Again, my remainder should be 0 because they're telling me this is a 0. When you plug in 8, 8 should be one of your x-intercepts, so you should get a 0 here. Let's check it and see what happens. 8 times 15. Let me grab my calculator. 8 times 15 is 120. Negative 119 plus 120 is 1. 8 times 1 is 8. Negative 10 plus 8 is 2. 8, or negative 2, sorry. 8 times negative 2 is negative 16. 16 plus negative 16 is 0. Again, this is a quick way to check yourself. You know they gave you a 0, so you should get 0 as your remainder. So right now, what do I know? I know that x equals 8 is a solution. Well, if x equals 8 is a solution, then that means I had the factor of x minus 8 to begin with. Down here, I'm beginning with x cubed, so this is going to be x squared, x to the first, and x to the 0th power. So I have, as in my second factor, 15x squared plus x minus 2. Now we always want to factor completely, meaning that we are looking for linear factors. X minus 8 is already a linear factor, so I'm going to go ahead and bring that down. I need to factor this completely. It's a trinomial, and so to factor this completely, I am going to do the area model. So remember, first term goes in the first box. Last term goes in the last box. You always want to multiply your first number by your last number. So I am looking for factors of negative 30 that add to my middle number of positive 1. Those two numbers are positive 6 and negative 5. Those are going to be the numbers that go in the empty spaces of my area model. 15x squared and 6x have a GCF of 3x. Negative 5x and negative 2 have a GCF of negative 1. 15x squared and 5x have a GCF of 5x. And then 6x and negative 2 have a GCF of 2. Remember that you can check your work. 3x times 5x is 15x squared. 3x times 2 is 6x. Negative 1 times 5x is negative 5x. And negative 1 times 2 is negative 2. So this factors to 3x minus 1 times 5x plus 2. But we aren't looking for the factors anymore. They want us to find the zeros. We want to know, what does x equal? So we need to set this equal to 0 and solve. From here, I can use the principle of zero products. This times this equals 0. So either x minus 8 equals 0, 3x minus 1 equals 0, or 5x plus 2 equals 0. So if I solve this first equation, I'll get x equals 8, which is good because that's what they told me. If I solve this second equation, I'll have 3x equals 1, divide both sides by 3, and get x equals 1/3. And for this last equation, I'll subtract 2 on both sides, get 5x equals negative 2, divide both sides by 5, and get x equals negative 2/5. So my solutions, my zeros, are x equals 8, x equals 1/3, and x equals -2/5. These are my solutions. And that's it.